in that area, it would have a very small number. And this turns out to be mathematically actually better design than the original design I showed in previous slides. So there was this first agreement from simple sort of wiring and neuroanatomy, and then mathematically shown that what actually nature has come up with, in other words, granule cells that have only a very small number of inputs, turns out to be mathematically a much more efficient way. And of course, in terms of energy consumption, is much more efficient. So now we'll see how the sparse distributed memory corresponds to random access memory. This is one way of looking at the RAM. Everyone has a RAM in their computer and cell phone and whatever. So here you have memory. You can think of it in this way. You have a memory address, and then you have, for each possible address, you have one location. So here it's a location 0, 1, 2, 3, 4, 5. And if you have 20 bits of address, then you would have about 1 million. The last address you reach, you would be 1 million. And so you do have one memory location for each one of those. So 20 bits would require you to have 20 bits of address would require you to have 2 to the 20 memory locations. Then when you put in an address, it activates only one location. This is because now you have every one of a possible 20-bit address actually is represented in this matrix. It means that it can select, once you give an address, it selects that particular location. Whatever data you want to write in that, it goes into that location, nowhere else. It destroys whatever was there before. Then you